The map is a lie. Every poster, every classroom diagram, every animation that shows the solar system as a tidy parade of worlds, all of it is a lie built from necessity. The distances involved are so extreme that if you tried to draw them honestly, on the same piece of paper, at the same scale, the planets would disappear. Not shrink. Disappear. You would need a canvas the size of a small country just to place two of them far enough apart, and everything between them would be blank. That blankness is not backdrop. It is the point. Most people spend their entire lives with a wrong picture in their heads. A picture where the planets are close enough to feel like neighbors, where the solar system is a busy, populated place, where space is something you pass through on the way to somewhere else. The honest version is harder to sit with. In the honest version, the solar system is almost entirely nothing. Rock and ice and gas account for a fraction of a percent of the total volume. Everything else is cold, unlit vacuum, and the vacuum goes on for distances that don't behave the way distances are supposed to behave. When you try to hold the real scale in your mind, something breaks, not metaphorically, cognitively. The numbers stop connecting to anything your experience can anchor them to. 1 trillion miles means nothing because nothing in your life has ever required you to understand what 1 trillion miles feels like. The solar system was built for a species with a much larger frame of reference than we will ever have. And crossing it in your imagination is not a matter of thinking harder. It is a matter of accepting that your intuition was designed for a planet, not for what surrounds it. Start with the sun. Almost everything in the solar system, roughly 99.8% of all the mass inside it, is packed into a single object. The planets, the moons, the asteroid belt, the comets scattered through the outer dark, all of it together makes up less than 1/4% of the total. One astronomy textbook describes the arrangement plainly. The solar system, it says, is the sun plus some debris. That framing sounds dismissive. It is just accurate. To feel what that means, hold a single model in your head. Stand the sun up as a standard doorway, the kind you could walk through without ducking. On that scale, Earth is not a basketball beside it, not an orange. Earth is a penny. One copper coin, roughly the size of a thumbnail, sitting 2 football fields down an empty corridor from that door. No air in the corridor, no light except what comes from the door itself. Just a long fall of black, and at the far end of it, a coin. Everything your species has ever done happened on that coin. Every war, every city, every face turned up at a night sky, every signal sent into space, every attempt to understand the place we occupy. All of it concentrated on a single copper disc, 2 football fields from the nearest fire. And here is the detail that does not land easily the first time. The only other surface a human being has ever stood on is a fleck sitting roughly 2 feet from that coin. In a corridor stretching 750 feet, every human who has ever left this planet covered the first 2 feet and turned back. That is how close we have gotten. That is the full scope of human expansion, measured against the actual scale of the space immediately surrounding us. The coin is not even remotely close to the edge. Move outward from the penny, and the gaps between worlds start to behave in a way that feels almost hostile. Jupiter is genuinely large. More than 1,300 Earths could fit inside it, with room remaining. That fact gets repeated often enough that it starts to feel familiar, almost manageable. The size of Jupiter is not the problem. The problem is the moat around it. The gap between Mars and Jupiter is so wide that you could take every other planet in the solar system, line them up edge to edge, and drop the entire chain into that single interval, and still not fill it. A bridge built entirely out of worlds would come up short. Most of that gap is the asteroid belt, which sounds dense and dangerous until you learn that spacecraft fly straight through it without adjusting course. The rocks are real, the crowding is not. They are spread across a volume so enormous that the average distance between any two of them is measured in hundreds of thousands of miles. Push past Jupiter, and the mood of the solar system shifts. Saturn sits nearly twice as far from the Sun as Jupiter does, and the loneliness out there becomes something almost physical. When the Cassini spacecraft was orbiting Saturn and turned its camera back toward the inner solar system, Earth appeared as a single pale point tucked beside the rings. Easy to miss, requiring an arrow in the image to locate. From that distance, the Sun itself had shrunk to a brilliant dot, no longer a disk you could shield your eyes against, just the brightest star in a very dark sky. The warmth it provides at Saturn's distance is comparable to a campfire seen from hundreds of meters away. Present technically, not enough to matter. And Saturn is not the end. Uranus sits nearly twice as far from the Sun as Saturn. Neptune sits nearly twice again beyond that. By the time you reach Neptune, you are roughly 2.8 billion miles from Earth. The signal from a radio transmitter would need more than 4 hours just to arrive, and you have only just finished with the 8 worlds we call planets. It would be reasonable, standing at the orbit of Neptune, to assume you were near the edge of the system. The assumption would be wrong by a factor that is difficult to overstate. Everything from the Sun to Neptune, all 8 planets, all their moons, all the rings and the asteroid belt and the space between, fits inside a single sunlit bubble of charged particles called the heliosphere. The solar wind, the constant stream of energized material pouring outward from the Sun, inflates this bubble against the thin gas between the stars. The boundary where the wind finally slows and stops, called the heliopause, sits somewhere around 11 billion miles from the Sun. That is roughly 4 times the distance from the Sun to Neptune. Only 2 objects built by human hands have ever crossed that boundary. The 2 Voyager probes launched in the late 1970s, more than 4 decades ago, and they have been flying ever since at speeds our fastest aircraft could not approach. Voyager 1 is currently the most distant human-made object in existence. It has been traveling for nearly 50 years. It is only just past the heliopause. It is, by any reasonable measure, barely outside that boundary, the one it took our farthest, fastest, oldest emissary half a century to reach, is the edge of the solar system. It is not even close to the edge. The heliosphere is simply where the Sun's wind dies. The Sun's gravity extends much, much farther than that. And what it holds in its grip in the outer dark is something the scale models never bother to include, because including it honestly would make everything else disappear. Beyond the heliopause, past the boundary the Voyagers spent decades crossing, the Sun still owns something vast enough that the entire planetary system, every orbit, every world, every distance that already felt incomprehensible, shrinks inside it to a small bright core at the center of a much larger structure. It is called the Oort Cloud. The name is calm and clinical, which is part of the problem. It does not prepare you for what the name describes. The Oort Cloud is a spherical shell of frozen material, comets, ice, rock, wrapped around the entire solar system at a distance that starts where the planetary region ends and extends outward to perhaps a quarter of the way to the nearest star. Not a disk, not a ring, a sphere, a complete enclosure, 3-dimensional in every direction, holding somewhere in the range of several trillion individual objects, so spread out across such an enormous volume that a spacecraft traveling through the middle of it would likely never see a single one. The inner edge of the Oort Cloud begins somewhere around 2,000 times the distance from the Earth to the Sun. The outer edge may reach 100,000 times that distance, or beyond. To cross from one side to the other, moving at the speed of the Voyager probes, would take somewhere in the range of 30,000 years. Not 30,000 days, not 30,000 months, 30,000 years. Longer than the entirety of recorded human civilization, longer than the oldest known cave paintings. From the moment the first scratched marks into stone walls to this conversation, right now would not be enough time to cross the Oort Cloud at Voyager speed. Hold that. The thing we casually call our solar system, the one that already broke your sense of scale with its empty corridors and its lonely outer planets, turns out to be mostly this: a vast dark shell of frozen debris extending in every direction, through which nothing we have ever built could pass in any time frame a human mind can honestly feel. The bright inner core, the part with the sun and the planets, and everything we have ever touched or seen, is a rounding error at the center. The numbers eventually stop landing. That is not a failure of effort. It is a structural feature of the problem. Human cognition was built on a savanna. It was optimized for distances that could be walked in a day, for timescales that fit within a lifetime, for quantities that could be counted on fingers or gathered into rough visual estimates. Nothing in that history prepared the brain for 30,000 years, or for 1 trillion objects too spread out to sea, or for a shell of frozen material so large that the 8 planets hiding at its center are, proportionally, about as significant as a single cell inside a human body. This is where most scale discussions stop. They hand you the Oort Cloud and let the number sit, and the number is genuinely stunning, and most people nod and feel briefly overwhelmed, and then the feeling fades because the mind has nowhere to put it. But there is one more step, and it is the step that changes what the earlier numbers mean. Because everything described so far, the penny 2 football fields from the door, the moat swallowing entire chains of worlds, the lonely campfire warmth at Saturn, the heliopause, the Voyagers barely crossed in 50 years, the 30,000-year shell of frozen debris, all of it added together. The entire solar system from the center of the sun to the outermost comet at the edge of the Oort Cloud is just one step. One step on a staircase. Star to our sun is Proxima Centauri, roughly 4.2 light-years away. Light, the fastest thing that exists, the signal that already needed 4 hours just to reach Neptune, takes more than 4 years to make that crossing. Written in miles, the number has 13 digits. If you aimed the Voyager probes at Proxima Centauri, which they are not, the journey would take somewhere around 75,000 years. And Proxima Centauri is not a destination. It is the next step. After it comes another, and another, all the way out to the edge of the galaxy, and then across the void between galaxies, and then across the void between galaxies clusters, and the staircase does not end anywhere. A human concept of ending applies. The solar system, which already felt impossibly large, is one grain of sand on a beach that extends past every horizon. That is the picture, not the poster on the classroom wall, not the friendly row of worlds in manageable proportion. The real picture is a single lit grain, adrift in a dark so expansive that the word vast fails immediately, and every word after it fails too. And what remains is something quieter and harder to put down. The question that follows from the real picture is not a small one. If the universe is this large, if there are hundreds of billions of galaxies, each containing hundreds of billions of stars, many of them circled by planets, many of those planets sitting at distances from their stars, where liquid water could exist, then the silence should be impossible. The dark between the stars should be alive with signals. The mathematics of large numbers almost demands it. And yet, for more than a century of increasingly sensitive listening, the sky has returned nothing that could not be explained by natural processes. No structured signal, no repeating pattern, no evidence, anywhere, of another mind. The void outside our solar system is not simply empty space. It is an answer we do not know how to read. There is a comfortable version of the silence. It goes like this: space is large, signals are weak, and our instruments are still primitive. We have been listening seriously for less than a century. The galaxy is roughly 10 billion years old. A civilization that emerged even 1 million years before us would have had time to develop technologies we cannot imagine, but we would only detect them if they happened to be pointing a transmitter in our direction at the precise moment we happen to be listening. The window is narrow. The galaxy is wide. The silence on this reading is simply a matter of timing and geometry. We are not alone. We are early or poorly positioned or using the wrong instruments. Give it time. This explanation is genuinely reasonable. It has real scientific support. Several researchers who have studied the problem seriously hold versions of it. For a moment, it is almost satisfying, the kind of answer that closes the question gently and allows the universe to remain a populated place full of minds we simply have not found yet. The problem is what happens when you press on it. In a galaxy 10 billion years old, even a modest head start matters enormously. A civilization that emerged just 1% earlier than we did, 100 million years ago, which is recent by galactic standards, would have had time, at even the slowest plausible rates of expansion, to spread across significant fractions of the galaxy. Not through science fiction, faster than light travel, through patient generational migration, through self-replicating probes, through the slow accumulation of presence across timescales that dwarf everything human civilization has ever experienced. 100 million years is long enough for entire mountain ranges to rise and erode and rise again. It is long enough for the ancestors of modern whales to have returned to the sea and diversified into dozens of species. It is, by any biological or geological standard, an almost unimaginable expanse of time. And yet, in that time, an expanding civilization moving at even a small fraction of the speed of light could have touched every star system in the Milky Way. Not once, many times. This is the calculation that makes the silence strange. It is not simply that we have not heard anything. It is that, given what we know about the age of the galaxy and the plausible mechanics of expansion, the galaxy should already be full. Not theoretically full, observably full. There should be signatures, engineering at stellar scales, modifications to stellar output, structures that no natural process would produce. The James Webb Space Telescope, the most powerful observatory humans have ever placed in space, has now surveyed galaxies at distances that represent the universe as it existed only a few 100 million years after the beginning. It has found galaxies that are larger, more structured, and more chemically complex than the models predicted for that era. It has not found anything that looks like deliberate engineering. Nothing that requires a mind to explain. The silence is not just in our radio receivers. It is in the data from every instrument we have ever trained on the sky. So the timing and geometry explanation, while reasonable, runs into a difficulty. Even granting every generous assumption that civilizations are rare, that signals are hard to detect, that expansion is slower than the models suggest, the numbers eventually stop cooperating. The galaxy is old enough, and the physics of expansion are permissive enough that the absence of any detectable signature anywhere requires an explanation beyond bad luck and narrow windows. Something else has to be doing the work. One possibility that astronomers and astrobiologists return to repeatedly is the idea that the silence reflects something about the nature of intelligent life itself. Not its absence from the universe, but the extreme difficulty of its persistence. Complex life may arise, intelligence may emerge, and then something happens. Not necessarily a single catastrophe, not necessarily a war or a plague or a climate collapse, but a threshold. Some transition point that civilizations routinely fail to cross, or cross in ways that make them invisible, or cross in ways that end them. The threshold does not need to be dramatic to be effective. It does not need to produce explosions visible from other star systems. It only needs to be consistent. If the overwhelming majority of civilizations that develop the capacity for interstellar communication also develop, shortly afterward, something that ends or transforms them beyond recognition the result would look exactly like what we observe: a sky full of stars, a sky full of silence. And here is where the timing and geometry explanation quietly collapses under its own weight. Because if the silence is just bad luck, if civilizations are out there but simply haven't reached us yet, or haven't aimed a transmitter our way, or are using communication methods we haven't thought to look for, then the silence tells us nothing alarming about our own future. We are simply early. We simply need better tools. The universe is populated and patient, and we will eventually find our place in it. But if the silence reflects something structural, something about what happens to intelligence at a certain point in its development, then the silence is not just an astronomical observation. It is a data point about us, about where we are in a sequence that most civilizations apparently do not complete. The quiet sky on that reading is not empty. It is a pattern, and patterns have explanations. The question is whether the explanation is one we are capable of wanting to hear. The explanation has a name. It is called the Great Filter, a term coined by economist Robin Hanson in the late 1990s to describe whatever process or processes are responsible for the absence of visible civilizations in a universe that should, by the numbers, be full of them. The name is deliberately neutral. It does not specify what the filter is. It does not specify when it operates. It only identifies the logical necessity. Something is filtering. Something is preventing the universe from filling up with the signatures of intelligence. And whatever that something is, it is extraordinarily effective. The filter could be behind us. This is the version most people find easier to hold. On this reading, the difficult step was not becoming a spacefaring civilization. It was becoming life at all, or becoming complex life, or becoming a creature capable of abstract reasoning and technological development. Perhaps the emergence of the first self-replicating molecule is so improbable that it has happened only once, or a handful of times, in the observable universe. Perhaps the leap from simple single-celled organisms to complex multicellular life requires a sequence of accidents so specific that most planets with life never make it. Perhaps the development of a large brain, of language, of the kind of recursive self-awareness that produces science and engineering, requires a combination of evolutionary pressures, so particular that it is effectively unique. If any of those steps is the filter, if the hard part is already behind us, then the silence makes a different kind of sense. We are not looking at a graveyard. We are looking at an empty lot. Life did not rise and fall across the galaxy. It simply did not rise, or did not rise far enough, or did not rise in the right configuration. We are the exception. The galaxy is not a cemetery. It is a wilderness, and we are its only inhabitants, capable of noticing how quiet it is. That version is uncomfortable in one direction. It makes us feel isolated, improbable, possibly unique. But it does not threaten the future. If the filter is behind us, the road ahead is open. The silence is not a warning. It is simply the sound of a universe that has not yet managed to do what we have done. We are early, we are rare, but we are through. The other version is harder. If the filter is ahead of us, if the difficult step is not becoming intelligent but surviving intelligence, then every civilization we can imagine, every mind that has developed the capacity to ask these questions and build the instruments to pursue the answers, eventually encounters something it does not survive. Not because the universe is hostile in any active sense, not because some predatory force removes civilizations before they can expand, but because something internal to the development of technological civilization, something that follows almost inevitably from the acquisition of sufficient power, tends to end it. The candidates are not exotic. They do not require inventing new physics or new disasters. They are recognizable. The development of weapons capable of ending a civilization. The destabilization of the planetary systems that support complex life. The emergence of technologies that have for goals, misaligned with the persistence of the civilization that created them. Any of these, applied at sufficient scale with sufficient consistency, would produce a galaxy that looks exactly like the one we observe, ancient, immense, and silent. And here is the detail that does not soften with repetition. We are not watching this from a safe distance. We are not astronomers studying a pattern in some other corner of the galaxy, detached and curious. We are inside the pattern. We are a young technological civilization that has recently acquired several of the capabilities that, if the filter is ahead, tend to mark the point where the sequence ends. We have weapons capable of civilizational collapse. We are in the early stages of destabilizing the climate system we depend on. We are developing artificial systems whose optimization targets we do not fully control, and whose long-term behavior we cannot reliably predict. None of this is certain. The Great Filter is a hypothesis, not a measurement. The silence could have other explanations. Civilizations might exist in forms we do not recognize. Communication might happen through channels we have not thought to monitor. The filter, if it exists, might operate through mechanisms than catastrophe, through the withdrawal of civilization from physical expansion into forms of existence that leave no detectable mark on the observable universe. But the honest version of the calculation does not allow easy exits. If the filter is real, and if it is ahead, then the civilizations that reached this point before us, the ones that developed radio and rocketry, and the ability to reshape their planets, did not go on to fill the galaxy. They went quiet. All of them. Everyone. Without exception, as far as we can observe, across 100 billion galaxies, stretching back nearly to the beginning of time. The penny on the corridor floor, 2 football fields from the fire, surrounded by unimaginable emptiness. It is not merely a picture of scale. It is a picture of isolation. And the isolation is either a consequence of how rare we are, or a consequence of what tends to happen next. There is no observation that can currently tell us which. What there is, instead, is the sky, patient, vast, returning nothing. And the question that the silence keeps asking, in every direction at once, is not whether we are alone. That question almost answers itself, one way or the other, in the emptiness. The question the silence keeps asking is simpler and harder and more immediate than that. It is asking whether we are paying attention. There is one more thing the scale conceals. Not a fact about distance, or about the age of the galaxy, or about the mechanics of expansion. Something quieter than that. Something that only becomes visible when you hold the full picture together. The penny and the corridor. The 30,000-year shell, the silent sky, and ask what it means to be the kind of creature that can measure all of this and still not know what to do with the answer. We are the only thing we know of that looks outward and wonders. Not just observes. Wonders. Builds instruments to extend the reach of senses that were designed for a small, warm planet, and points them at distances that would have been meaningless to every ancestor we have ever had. The cognitive machinery that allows a human being to understand that the solar system is mostly empty, that the nearest star is tens of thousands of Voyager years away, that the silence of the sky might be a pattern with a structural explanation, that machinery did not evolve for this purpose. It evolved for finding food, for reading the intentions of other people, for navigating a social world of maybe a few dozen individuals. It was repurposed, imperfectly, for something it was never built to do. And yet here we are, doing it. There is something in that fact that does not resolve into either comfort or despair. It sits between them. A species that emerged on a copper penny, in a corridor of cold vacuum, around an unremarkable star in the outer regions of an average galaxy, in a universe containing somewhere between 100 billion and 2 trillion other galaxies. A species that evolved to survive, not to comprehend, has nonetheless managed to comprehend enough to know how small it is. That is not nothing. It might, in fact, be the most improbable thing we know of. But improbable is not the same as safe. The window in which a civilization can ask these questions and still act on the answers is not unlimited. The same development that produced radio telescopes and space probes, and the capacity to measure the scale of the observable universe, also produced everything that populates the other end of the great filter calculation. The tools are the same tools that allows us to detect the signatures of other worlds, is continuous with the knowledge that allows us to alter the chemistry of our own atmosphere and design systems, whose behavior exceeds our ability to predict. We are not at the beginning of this. We are somewhere in the middle of it. And the middle is where, if the pattern is real, things tend to go one way or the other. The penny does not know it is a penny. That is the part of the analogy that breaks down, and it breaks down in a direction worth paying attention to. The coin in the corridor has no awareness of the corridor. It does not measure the distance to the door. It does not ask whether other coins exist in other corridors, or whether the coins that came before it found a way through. It simply sits there, in the dark between the fire and the nothing, reflecting whatever light reaches it. We are not the penny. We are the thing on the penny that looked up. And what we have found, after a century of looking, after all the radio dishes and the orbital telescopes, and the careful analysis of every signal that arrived from every direction, is a universe of almost perfect stillness. Not the stillness of emptiness. The universe is not empty. It is unimaginably full of stars, and galaxies, and the raw material of chemistry and time. It is the stillness of voices that are not speaking, or that spoke and stopped, or that never quite managed to begin. The distinction between those three possibilities is the most important question our species has ever been unable to answer. The corridor is still there. The penny is still there, 2 football fields from the door, in a dark that extends in every direction, past the Voyagers, past the Oort Cloud, past Proxima Centauri, and every star beyond it, out to distances that took light longer to cross than the Earth has existed, and the fire at the end of the corridor is burning, for now. For a few billion more years, probably, before it exhausts the hydrogen at its core and begins to change in ways that will make the penny uninhabitable. A few billion years is a long time, long enough, in principle, for everything. Long enough to solve the silence, or to become part of it. Long enough to find out whether the filter is something we already passed, something waiting ahead, or something we are building, right now, with the same hands we used to build the instruments that showed us how alone we might be. The sky does not offer an opinion. It offers only what it has always offered: distance and stillness, and the faint light of 100 billion fires, none of which have answered. We are still listening. We just do not know, yet, whether that is a sign of how rare we are, or a sign of how little time we have left to listen.